Okay. Man, this is taking longer than I thought it was going to do. Number 3. Pick a card, any card. You draw a card from a deck. If you get a red card, you win nothing. If you get a spade, you win $5. For any club, you win 10, plus an extra $20 for the ace of clubs. Create a probability model for the amount you win at this game. Okay, so I've got values X, and I've got probabilities of X. But what I'm going to do is I'm going to add some more space here. Now, obviously, because I want to do this, and I'm going to create the mean and standard deviation, I'm going to have X sub I and P sub I down here. I'm going to have this row. Okay? But the other thing I'm going to do to help me clarify this is I'm also going to have some information up here to tell me what the card is. Because if I think about it, this has to be a value. And what it says, if I get, like for example, it says if I get a spade, I get $5. Well, I can understand what a spade is, and I can understand the probability of getting a spade, but spade times probability means absolutely nothing. So this has to be a numerical value. So that numerical value is going to be based off of the card. So I'm going to add another row called the card. Okay? Now, let's go through. If I get a red card, it says, then I actually get nothing. So my value for X is 0. And then I talk about the probability of getting a red card. Okay, what's the probability of getting a red card? Well, the probability of getting a red card is 26 out of 52. That's also 0.5. I'm going to write it as 26 over 52, and we're going to see why in just a second here. Okay? Now remember, we said we don't reduce in probability. All right, I could get a spade. If I get, I'll extend it. If I get a spade, then I win $5. And what's the probability I'm going to get a spade? The probability I'm going to get a spade is 13 out of 52. Next up is that I could get a club. And if I get a club, that's worth $10 to me. The other thing it tells me that I could get the ace of clubs. Now, if I get the ace of clubs, I get an extra $20, which means that card itself is worth $30. Okay? Now, why is this important? Well, I need to think about this. The probability of getting a club is 13 out of 52, but what's the probability of getting a $10 club? And the probability of getting a $10 club is actually 12 out of 52, and the probability of getting the ace of clubs is 1 out of 52. Now, why did I make it out of 52? Because now, by having it all out of 52, I can see that these probabilities all add to what? 1. They have to add to 1. So now I can see, because I've got the same denominator easily, that they all add to 1. Alright, so now what I'm going to do is I'm going to find X sub I, P sub I. So X sub I, P sub I, 0 times, I can do this one in my head. That's 0. Woo, I'm good. Alright, this is a quarter, 0.25. So I'm looking for a quarter of 5, which is 1.25. And this is 10 times 12 over 52. That's not necessarily as easy. But you know what? Why wouldn't I use my calculator on this? I don't know. I should, because that would make sense. All right, so here let's go. Stat, edit. Let's go to I don't want to erase. Let's go to L3. L3, my values are 0. I don't know why I have that minus something there. I hate when that happens. Okay, 0, 5, 10, and 30. Alright, so what do I put in L4? Well, I'll just put it in exactly as I see it. It is 26 divided by 52. That's fine. It will do the division for me. Hey, look, it says 0.5. Not like you can see on the blurry screen. But because you're doing this with me, with your calculator says 0.5. Okay, $5 is 13 divided by 52. $10 is 12 divided by 52. And $30 is 1 divided by 52. Enter. So what this says is that the probability of getting $5 is 0.25. The probability of getting $10 is 0.23077. I can barely read it myself. And the probability of getting $30 is 0.01923. So what I want to do is I want to find out what these values are. I'm going to actually make my life a little bit easier because I'm going to go to L5, and I've got stuff in L5, but that's all right, it'll go away in just a second. And I'm going to go up to the menu, and I want to take X sub I times P sub I, which in this situation is going to be L3 times L4. There we are. There's my values. 0 for a red card, 1.25 for a spade, 2.3077, but we're going to make that 2.31. And why am I rounding to 2 decimal places? Once we said on anything that we do, standard deviation and mean, we're going to round to 2. Probability, we round to 4. But why am I rounding to 2 specifically here? It's money. It's money. Money, 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 money. Oh, that's I sing well. All right, 0.57692, which would be 0.58. And as I do this and the picture goes away, we'll go left and we'll come back, and the picture will come back, and the picture will come back. Really will. All right, so now, there's my probability model. All right, so what's the mean? Summation of x sub I, p sub I. Add these together, you're going to get $4.14. So, if you were to play this game a whole bunch of times, what's the average amount you're going to win? $4.14. If you're going to play it once, how much would you expect to take in? $4.14. How much should you be willing to play this game? At most, $4.14. Because otherwise, on average, due to the law of large numbers, you're going to lose money. As a casino, how much money are you going to charge? And you're going to charge more than the expected value. It could be a penny more, because over the long run, you're going to make money, $4.15. What's standard deviation? Standard deviation, I can find standard deviation fairly easy. I would go to stat, I would go to calc, I would do, in this situation, I'm going to do L3, comma, L4, and I get a standard deviation of 5.44. Average distance from the mean. Okay, next time, and I have to be done here because we got class coming up. We're going to look at 23, and we're going to start looking at combining random variables x and y, and we'll look at combining random variables. So there we are for this problem, and we'll just move on.